Hello and welcome to the Innovation Coffee live stream brought to you by ARM. My name is Robert Wolf, and in this episode, we'll be meeting with Angel Riveria, Senior Developer Advocate with CircleCI. Deep breath, I'm out of breath. I've been setting all this stuff up this morning. All right, with Senior Developer Advocate from CircleCI. CircleCI is a CICD or continuous integration and continuous deployment platform that allows companies and developers to automate their building, testing, and deployment of software. We'll leave it to our expert on the call to elaborate further on what CircleCI is and what CICD is and how it can be used for real-world solutions. But before we introduce today's guest, we will be doing a quick recap of last week's episode and providing a special redemption segment. So in last week's episode, we had quite a few people join us. Representatives from Altium, Raspberry Pi, and the Drone Code Foundation came together to talk about drones. It was a fun episode that ended up with a demonstration that didn't quite take flight, and pun intended there. We're joined today once again by Andrew Smith of Altium, who worked tirelessly after last week's stream to provide us with a video of the drone finally taking flight. So Andrew, let's bring you in here and welcome once again to the stream. Hello, Andrew. How's it going today?
Good, Robert. Thanks for having me back here.
Yeah, of course. So we have the video queued up here, ready to go. But before we hit play, maybe you can kind of tell us a little bit about what went wrong last week.
Really, it's one of those things that you check certain things, and there's one little tiny thing that catches you every time. Those of you familiar with a mission mode switch, basically kind of turning what mode that your flight's operating in. In this case, there's a switch on the RC. So I mentioned last time I had my kind of backup pilot or safety pilot. I forget exactly what I called it. That was there in case the helicopter decided to go off into a different direction. They can flip a switch and then kind of take control back. That was never flipped over to the switch that said, off board, letting the computer have it. And so that as soon as I went and flipped that switch, ran the code, boom, it went. And so it was as soon as we were off air, a minute later, it was done.
I think we'll chalk it up to insufficient sacrifice.
Sure, yeah. To the gods, yeah, absolutely.
All right, so we're gonna get that video going now, and when I hit play, feel free to talk us through, just to let everyone know who's watching. It's about a minute and a half. So Andrew's gonna talk us through the whole process and what he's doing while this video plays. And our producer behind the scenes is gonna click that video. Rachel, you got that? There we go. All right, you're up, Andrew.
There you go. So it's running. So what you see here in the two, let's do the videos. The video on the top is a video that's running a camera that's behind the scenes, or not behind the scenes, but off the corner. It's going to try and track it. And then the one below it is an onboard camera that's running through the CM4. It's got a Raspberry Pi camera on there, going through a Coral TPU. And there's my pilot right there, kind of getting out of the way. I took control. And it's running a basic or very standard Google Coral TensorFlow demo that's straight out of their Git repository. Nothing really done there other than I kind of pieced it all together. On the left side, the left terminal window is a ROS2 interface that I'm on my desktop computer that I could run. Right there, you can see I started it up, and the right one's just showing the status from the robot. So there you can see it took off. And it goes to about 5 meters. And as it went up, it rotated. I think it's going to rotate 9 degrees. And then I'll shut off the control. You'll see it in the left terminal right there. And now it comes in for a landing and smoothly, in quotes, touches down nearby where it took off from. And that's pretty much it. That was the offboard control example, was just meant to be, a very straightforward, simple example, but you can imagine you can program that to do anything. A really cool thing would be actually getting some sort of feedback coming from the camera that's trying to track something, and it issues commands to the FMU so that it actually goes and follows whatever you see there, and it tries to keep it in the center of the frame, something like that. Maybe that'll be the next demo we put out.
Yeah, that's awesome. Andrew, thank you so much for coming back onto the show to showcase this. And I think redemption achieved. If we had a badge to give you, we'd give it to you. So yeah, let's definitely keep in touch. So, one day we can bring Altium yourself back here to showcase some more stuff another time.
Absolutely. Thanks. So we've got the code that was used in this. We posted it to our GitHub repository. It's try to containerize everything, so it's all Docker containers that you shouldn't have to recompile. You should just download it to it and just run it. So I'm trying to make it really easy. If you have troubles running it, post an issue in the GitHub. We'll fix it. But hopefully this kind of gets you up and running and just testing and flying. So good luck with that.
Yeah, that's
Thanks,
great.
Robert.
And yeah, of course. No, thank you so much once again for your time. And as you can see right here below, we did post that link of Andrew's GitHub where you can find it bit.ly/gumsticks/firmware. There you go. All right, Andrew, we're going to take you off the stream now. Thank you. All right. Take care.
You too.
All right. So on to the main segment now. Please join me in welcoming Angel Riveria, Senior Developer Advocate at CircleCI. So Angel, welcome to Innovation Coffee. How you doing today?
Hello, Roberto, Robert. How are you, man? I'm doing great.
Bien, gracias.
De nada. So I'm really excited to be here and talk about continuous delivery, CICD, DevOps, ARM, or whatever else you want to talk about. So yeah, super excited. Thank you.
That's great. Yes, no, we're happy to have you here. Thank you for spending the time with us. And usually as we do in these shows, we like to start off with a bit of an origin story. So we have you here. Tell us a little bit about yourself. Who is Angel and what do you do?
Yeah, so I was born in like 1876. I have an adamantium skeleton and claws. No, I'm just kidding. No, my name is Angel Riveria. I started off my career United States Air Force Space Command. I was working in the early 90s as a space lift operator. So that meant basically I was helping astronauts and the space lift programs achieve success through ensuring that the what we call the range is the area where things get launched into was free and clear of any kind of aircraft, ships, right? So helping with that mission, basically public safety. But I did learn a lot about technology through that experience and actually gained a great passion for programming systems, primarily back-end systems at that time. And ever since then, I've just been working as an integrator. So a lot of the work I've done throughout my career has primarily been making systems talk to other systems, reliably, confidently, and it's been a great ride. So I have a wealth of knowledge in hardware, security, building applications and services in the web and the cloud. So yeah, it's a really exciting career. I had a great time kind of building that. And today I spending my time not writing product code, right, or code for product, but more for demonstrations like this to help developers understand, the technologies out there in the industry today and how to leverage them to basically make their lives easier, right, in their jobs. So that's my origin story. I'm from New Jersey, so I don't know if that is appealing to anyone, but yeah.
Were you on Jersey Shore?
Oh no.
I mean the place. Like, did you ever go to
oh yeah, of course. I mean, yeah, I wasn't on the show.
Yeah.
So my son and I are now watching that, and he's just appalled.
Yeah, I think that's what everyone has, that impression of Jersey. When you say it, they've never been or don't know anyone from there. But yeah, and then South Park did an episode on it to further, the stereotypes. But yeah, anyways, cool. Another tidbit about you: you speak fluent Spanish. You and I have had several conversations. We could give this entire episode en español.
Yo no sé eso, pero podemos tratar, right?
Intentamos. No, I'm just kidding. We'll keep it in English.
Yeah.
But yeah, cool. So joining us from CircleCI. Now, we're going to dive in deeper into this, but I want to kind of cover all the bases here. Tell us a little bit about what CircleCI is and what CircleCI does.
Yeah, so essentially, before I talk about CircleCI, let's talk about the concepts and the principles that CircleCI kind of facilitates, right? So with continuous delivery being adopted and implemented by pretty much every software producing team or organization, those practices and principles are essentially ways to build your software in a repetitive, consistent manner. And it also enables teams to kind of figure out how they want to build that software, right? So they can establish processes around, which we call continuous integration, right? So that tends to lean, when you talk about continuous integration, that leans towards the practice of, breaking your tasks out into smaller chunks, more manageable chunks, and then being able to kind of distribute them. So following that agile methodology, right, of developing software. But so yeah, you take, you give your team or your individuals tasks, and then the continuous integration piece is there's a few simple rules, right, like core rules around that, and one of them is, writing code in small chunks and then pushing those changes that you make to a repository, shared repository. And you're continuously doing that, right, throughout the day. You're making a change, and when you think you got it to a good, you got these changes or the changes you're making to a good position to be shared, then you push that up, right? So you could do that, twice a day, 3 times a day, depends on what team you're on. But once you have those rules and rules established, your team is now collaborating around code, right? So if you're constantly pushing your changes, and maybe you have a teammate that overlaps, right, in touching some of the same code, you can now have a conversation about like who's going to touch what first, right? Or the changes that were made. And it's really cool because now you're no longer like making changes and then waiting 3 weeks, right? And then figuring out that, oh, wow, all the work that you did and someone else did is now kind of you need another week to kind of untangle all those merge conflicts, right? So that's what continuous integration kind of does. So that's the CI and CICD. And again, these are practices and principles. So again, when you're having that process internally, you're going to need some automation, right? So the way that this works is I've pushed some code. The ideal way it works is I push some code, and instead of me running my like unit tests or smoke tests or even integration tests manually, I just make my code changes, push it up to my shared repository, and then from there, an automation platform like CircleCI, which is what we do, detects those changes. And once it detects those changes, it executes what we call a CICD pipeline or a pipeline. And all that is a set of instructions that automate the things you would do normally, you would do manually, on your laptop. So now you don't really have to worry about it. All you really have to worry about is if those the pipeline that executed, if everything passes successfully, right? So now you basically automated all of those things you do manually into a pipeline that you don't really even have to worry about, developing at all in general, right? Once you kind of set that, it's kind of like an autopilot, right? So it's just validating your code, it's checking tests, whatever it is that you instruct that CI/CD pipeline to do, it's going to do. And I'll demonstrate that a little bit later if it's not really clear. But at the end of the day, what CircleCI is a company that provides a platform to ease all of that automation, right? So if you were going to do this, like you roll your own CI platform, CI/CD platform, which I do not recommend at all. I actually wrote one once years ago, and I should have just used, the resources available to me through open source or whatever. It was very painful and hard to maintain. So don't roll your own. Check out what's out there. Definitely check out CircleCI. We are one of the best, if not the best, out there. But we bring that platform we make this platform available to developers, DevOps teams, anyone who's basically involved in the release of software. This tool is happy. I'm reading the screen, but it is happy. It is a happy tool for sure. Like I'm super happy when I use it. It's definitely like very useful, right? For just getting stuff done quicker, right? That's what we're all about is, finishing our tasks and, sending it off to some automation and only let me know if I'm having issues, right? So that's the whole point of like what we call a feedback loop. You only want to know when you have exceptions, which are failures, right? And failures are okay. Like I actually get suspect when I'm, working on a project and maybe I haven't had a failure in a few commits, right, or pushes, I get kind of nervous, like, whoa, what's going on? This can't be right. Like, so, I'm not that great of a programmer that I don't make mistakes. So essentially, like I said, CircleCI is just a platform that brings that automation, and it's geared towards developers and people in that software release process or cycle.
Yeah, and
does that make sense?
100%. I mean, we'll see what the audience says. That to me that made sense. And we also have a really cool demo. So Angel is going to be sharing something towards the end of this episode. It's a really cool demo that takes in multiple components. We're going to be using Terraform. We're going to be using AWS, and then we're going to be using one of the new ARM offerings that CircleCI has for deploying something. So stay tuned for that. That's going to be a really fun demo at the end. Now, I want to do a little icebreaker. I know we've already kind of ice broken here, but we have a really fun segment, and let's get that going. What do you have on your desk? I know you
Who
go ahead.
produced that jam?
I know, it's pretty cool, right? Yeah.
Is that you on bass, or
all credit to our executive producer Rachel? She's behind the scenes. She handles all of this really cool stuff that we get to show off.
Cool. I met her earlier.
So let's see what you have on your desk. I'm interested.
Oh yeah. Sure. So I probably forgot to mention in my origin story that I did work in a startup prior to CircleCI, and we were focused on IoT. And so I got the fever, or the fever to working with this kind of technology called LoRaWAN, which stands for, and it's been a minute, but was it LoRa is long range, low power. Yeah, something like that. Yeah, anyway, I screwed that up. But anyway, it's been a minute. But I spend my time, I used to spend my time before doing all kinds of events and stuff, working with the LoRaWAN technologies. This right here is my LoRaWAN gateway. What this does is interprets or receives signals in the US. The protocol, I think, is 986 or 915. I think it's 915 frequency. And basically what it is there's IoT type devices. This is a LoRaWAN board that I can attach. There's another board, a hat that we can put on. And basically I have a ton of sensors here. There's growth sensors. And I used to do quite a bit of hackathons. So it was quite fun to build, kind of hack devices and applications based off of the LoRaWAN technology. One of the coolest things I built was a project I called Bubble. And all it was designed to do is measure the volume of a container. So like the idea was a friend of mine had a problem with a septic tank and he was complaining about it to me. So I built a project that he can connect a LiDAR, which is a laser ranging kind of a technology that can sense how much let's say a container, let's say you have a bucket, how much volume is in that bucket, right? And it could send off an alert to him, so he won't have that overflow problem with his septic tank anymore, which is very costly if you don't know or don't have a septic tank.
I wouldn't want my septic tank overflowing. I don't have one, but
man, that's pretty nasty stuff if that happens. Yeah. So.
All right, cool. Well, thank you for sharing what you have on your desk, and it's very exciting to hear all the cool stuff that you used to do around LoRaWAN. We did kind of touch. You kind of touched on CICD, what CICD is when you were talking about CircleCI, but I want to dive a little deeper on this one before we go deep into this topic. Yeah,
let's do it.
So CI stands for continuous integration. CD stands for continuous deployment. Can you maybe just tell us a little bit more about what CI/CD is, kind of big picture, what developers can use this for? Like, what is CI/CD used for in the real world?
Right. So as I mentioned earlier, right, like continuous delivery is, like, I would say, the more generic term for all of this stuff. But CI/CD specifically is essentially, like I said, a continuous integration, which is the process of developing software in a structured fashion. And again, the core tenets to continuous integration are continuously pushing code updates to a shared repository and then teams and individuals collaborating around those code changes, right? So that everyone's kind of aware of what's happening with your work, and you're also aware of what's happening with other folks' work, right, on your team. So again, it's just designed to basically make people self-aware, or help people work better together, right? Like, so, as developers, we kind of go in our little silos sometimes, and we don't really communicate that well. These practices are designed to help, tease that out and help people, kind of build that collaboration, those collaboration skills, right? And we just work better together, more efficiently. And that's the goal, is to, get developers to focus in on what really matters, which is writing code, and then, using an automation tool like CircleCI to help them kind of just, send that snapshot of their work off into the automation, and then kick off a CI/CD pipeline. And at the end of the day, the main result is, a feedback, some form of feedback, either success, pass, or fail. If you fail, obviously you want to, go back, see what happened, figure it out, fix it, send it off again, right? And hopefully you that next fix will be the last fix for that particular incident or failure.
Yeah.
Yeah, good.
Well, I was going to say, in a lot of ways also, like using CICD, especially on heavy compute required projects, like things that require, crunching of a lot of stuff. You can put these things on more robust platforms, right? Like we're going to see today on like AWS Graviton 2. You can put these on some heavy platforms that can handle some heavy workloads, and then run that continuous integration deployment thousands of times, to test this thousands of times. Whereas if you try crunching this exact same thing on a Raspberry Pi, like just for example, like the OpenCV library, right? Like OpenCV, to build OpenCV, it could take you hours on a Raspberry Pi, right? Whereas you can do it much quicker on a much more robust platform.
Right.
So you could run this CI/CD thousands of times on one platform, get it working, and then once it's working, then you move it over to your embedded device.
Right. So one of the benefits, like, of CircleCI specifically is, we just enable developers to, again, focus on their code. And the reason is they only focus on their code is we run all the infrastructure, right? So imagine we're actually, doing millions of builds per day for our customers, like on a platform. So we're doing continuous integration and continuous deployment at scale, right? So the whole idea is you don't have to worry about that CI/CD infrastructure. CircleCI manages all that for you, right? We're very proud of what we've done so far, and like I said, I was a customer before I became a client, or not a client, but an employee, and it was pretty fascinating to learn, kind of the how the sausage is made on the back end, right? Because you don't really see that as a customer. And, it was pretty amazing at how the CircleCI engineering team was able to kind of provide that those resources as almost seamlessly, right, to the customer. And that's what we kind of want to do is take away all that, technical debt and all that, that worry that maybe not only a developer has, but the operations teams, right, that have to manage these CI/CD platforms. Like, there's plenty of other platforms. There's open source projects out there that you could implement, but you have to manage the hardware, the networking, the electricity, the data, the servers, right? All of that stuff goes away with CircleCI's cloud offering. Now, we do have an offering as well for like enterprises or regulated organizations that are under certain regulations that they have to maintain their data or their services in their own private kind of cloud or data center. So we have a flavor for the developer, the teams that don't want to manage that infrastructure, and we also have a flavor for the teams that have to manage infrastructure, right? But I focus mainly on the cloud because that's more fun, and I think more developers are interested in not having to worry about right that headache of having to run all that infrastructure and then maintain it, right? Because I can tell you, once you start adopting this stuff or this continuous delivery processes and you implement it in your teams, the CICD platform becomes critical, right? So if it goes down, now your team is used to, right, just pushing code. They're not going to have that feedback loop, right? They don't have that pipeline that automates all those things that they do, right? So when it's down, imagine a developer is just sitting there kind of waiting. I mean, I'm sure most developers, they're pretty, what do you call it, resourceful, and they'll do something, right? But at the end of the day, it's not going to be, it's just breaking that process, right? So
I remember talking to, previous job, Lenaro. I remember talking to some developers, like, when you start building the kernel, that's the time when you go make your food, brew a new pot of coffee.
Yeah.
You're still working. Yeah. So we got a question here from the audience. Carlo, he's asking, this is when you were answering the last question here, but Carlo says, Angel, would you say that CI is better for teams and non-CI for lone developer projects? We have some comments here from other people in the chat as well, but we'd like to hear what you have to say.
I would recommend, if you're a developer in this day and age, get on board with continuous integration. At a minimum, understand what it is as a practice and a principle. And if you can, start implementing some form of your own processes for developing software. Even as a lone developer, you can still implement CI/CD. You can still implement some form of continuous delivery automation, right, in your processes, because this is where the industry is going, right? It's not going to look back. There's no more of the hey, I'm just going to run this process on the server under my desk. All that stuff is kind of going away. Companies are really, really serious about releasing software at a very fast pace, right? So I remember when I started, operating systems were getting updates like a year, 2 years, 3 years, maybe 5 years, right? Today, that's not really the case, right? There might be smaller patches and updates, but they're continually coming, right? It's like maybe once a week or whatever. But at the end of the day, companies are releasing software faster, and it's not going to, ever go back to the way it used to be. So yeah, learning those concepts is really, really critical for modern day developers, because it's only going to be more widely adopted, these practices and principles. I mean, yeah.
Yeah. So
I hope that answers your questions, Carlo. Question, Carlo.
Yeah, Carlo. Yeah, I think it does. He'll let us know if it doesn't.
Please do, man. Shout out.
So other comments came in. I was mentioning using CI/CD for bigger builds, and iShot JR, one of our veteran community members here, he says he even uses it for trivial Pebble apps.
That's right.
Smaller apps, you can use it for that stuff
Pebble,
as well.
Man, he's bringing me. I got a Pebble watch upstairs that I'm about to retire, but yeah,
you'll definitely want to talk to iShot JR about Pebble. He's a good person to talk to about that.
Yeah. Awesome.
So let me see. There is one more question here I'll take from the community before we move on to more of my questions. This is from Tyeth, and he's asking, is there a local version of CI or CircleCI for local dev environments adding to this to avoid outage issues, or is it just up to the dev team to set up such processes?
Yeah, so unfortunately, outages do happen, right? That's one of the kind of drawbacks. So there is what we call a CircleCI command line interface or command line tool. You can do like a search for CircleCI CLI, Charlie Lima India, and you should be able to pull up like how to install it, right? And what that does is enables you, right, to kind of build pipelines locally, right? If you're talking about, right, like if there's an outage of some sort or whatever, then the answer is, unfortunately, there is no like mechanism unless you have a CI, which we talked about the kind of the CircleCI server locally, right? Then maybe you'd be able to continue on. But if you're using the cloud version, there's an outage. Unfortunately, you're at our mercy to fix that. But we usually tend to get those things fixed rather quickly. We understand it's super important. It doesn't happen often, but when it does, we're on it quick. Our teams are really, really good about it. But to answer your question candidly, No, you're going to have to figure out. I would just say keep writing code and figuring out what happens there later.
When an outage hits, just go to your code, keep writing while you wait for it to come back.
Yeah, or you can tweet at me and yell at me. I'm good. We can have a conversation. But yeah, I'm totally. Well, here you go. Like local build agent, something like that. Yeah. So right. So you have the we were talking about the CircleCI CLI. You can use that to build and test your CI/CD pipelines, or I should say your jobs within your CI/CD pipelines, so that you can ensure that your YAML's like legit, because YAML has indentation requirements and stuff like that. So yeah, there are some that's the only kind of real, I would say, offline developer tool, local developer tool you could use. And if you have any questions about it, yeah, just reach out to me or our team at our Discuss site. We can totally help you, get that set up or help try to solve any issues that you may have with that.
Posted that right down here too. We have a whole list of banners to share here for Angel when he mentions things. Cool. So thank you, Angel. And yeah, we did get some comments here. I shot JR when you mentioned retiring your Pebble. Retire it.
No, yeah, I love the thing, but it's to the point where I know there was a project called Rebel, I think. I don't know. It's harder to get the software now. But you know what? I shot JR. Hit me up on Twitter and let me know of any resources, because I don't want to get rid of it, but if I can extend it. It still works. It's great. I love the thing.
Yeah, there you go. And you can see his Twitter handle right there on his name tag right there at Punk Data.
That's it, man.
Cool. So here we go. Let's see. Next question I have. CircleCI has been around the block, and I'm sure you have done a lot of really cool, or seen a lot of really cool real world use cases and solutions being implemented on CircleCI. So I'm wondering, could you share with us one or maybe two, or just a real world use case solution that you've seen implemented using CircleCI?
So the PyTorch project is basically being built by CircleCI, and we've been working with Facebook, which is the sponsor of that project, to provide CI for that. And they build. I mean, obviously, right? That's a big project, and they use quite a bit of compute, and they leverage a lot of GPU, right? So we had to add more capacity on the back end, right? So CircleCI, like I said, is provides that infrastructure, but we also provide the underlying compute nodes, and we had to add, GPU capabilities, or compute nodes with GPU capabilities, so that they can leverage, the extra horsepower to produce that project, right? So whenever they make changes, it kicks off a CircleCI build pipeline or continuous delivery pipeline, and does the things that are embedded in that. So that's a huge open source project that is actually being built on top of CircleCI's platform. And it's pretty cool stuff. I got to say, that project keeps us on our toes for sure. But cool. That's one real world kind of, a project that's massive, right? And it's leveraging CircleCI, the platform.
And I'm sure there are many more. But
that's just one of the bigger ones that I come to mind that I really like, because it's open source. It's free to the community, things like that.
Yeah, and if we kept talking about all of them, I'm sure we'd run out of this hour real quick.
Yeah, I feel you on that. Feel you.
So next question I have for you is around the new CircleCI ARM offering. So earlier this month or later last month, CircleCI announced a new ARM offering. You wrote a really amazing blog, which we are going to share shortly when you go through your demo. But could you highlight what this means for developers? What does a CircleCI ARM-based offering mean for developers? More specifically, I think ARM developers, right? But yeah.
Yeah, well, I think developers are just developers, right? When you write code, you don't really care where it's going to be deployed to, right? You want to make sure your code is doing whatever what your specs and requirements demand it to do. So it's a funny space we're in, right? So with hardware, as usual, right? It's always proprietary or some weird thing going on. But the app, I always say, code is agnostic in a sense when it comes to hardware. It doesn't matter where it's going to be, executed. But what does matter is how you compile and package that code up so that, it will run on specific hardware. And this new, fairly new resource class is what we call it, or compute node, otherwise known as compute nodes, that we've added is really, really cool because now, right, maybe ARM, I don't want to say ARM developers, but maybe developers who built code are frustrated because, wow, I can't build my code natively, right, in this platform for ARM, right? Like I can't package up my app for an ARM deployment. So one of the things that that was really impressive for me, at least, was the team kind of recognized that ARM is gaining popularity, and we need to address that, right? We need to give the developers a solution to natively being able to package up their applications within their CI/CD pipelines and targeting the ARM architecture. So that was kind of the motivation behind adding what we call ARM resource classes. And resource classes, again, are just the type of underlying compute node that will basically execute your CI/CD pipeline. So think of it as like a server, right? That's just running your CI/CD pipeline, executing all of those commands in your pipeline. They have to be, right? So if you're packaging up something for ARM, you have to compile it on an ARM, native ARM processor or architecture, right? Underlying compute node. So yeah, this is really exciting because we now are able to give or enable the developers to leverage, right, building their applications for an x86 target architecture, and then also now an ARM target architecture. So you have the best of both worlds, and right, it's all integrated into one. You can integrate that into one pipeline, and it's just massively cool because there's not a lot of work to be done except for, hey, all right, just create this compilation job for this ARM platform, if that makes sense.
Yeah, I remember, again, coming from Linaro, right? We're always building kernels and doing all sorts of firmware stuff. Now, granted, I never got so deep into that, but I do remember building stuff, and I do remember using cross compilers. And when you're building on an x86 machine, you have to use a cross compiler to build for an ARM machine. And so building on ARM for ARM is becoming less and less of a dream and more of a reality every single day. And with, companies like CircleCI bringing these ARM offerings out, AWS putting out their Graviton2 chipsets, all these other companies that are putting out these ARM-based chipsets, I mean, it's just amazing to be able to build something and run it without needing to go through these cross compilations. I remember in my earlier days, I didn't cross compile. I didn't build so often. I didn't build so often enough that every time I needed to build, I actually needed to go back and figure out how to set up my cross compiler. So it was a pain in the butt, right?
Well, no, not only that, those cross compilers are also probably emulating, right, the hardware to enable that. That's basically how most of that stuff is done. And I love emulation. I think it's awesome. I think it has its place. But when you're compiling, like, let's say, mission critical, software, and you're doing on emulation, there's still that, like, it's not 100%, right? Like, you're emulating things. When you're doing this, when you're compiling on native ARM hardware, then all of that kind of, what I would say, risk goes not 100% away, but it gets way more diminished, right? So that app you was compiled using the proper hardware, and it just eliminates the risk of anything going wrong that's associated with something like an emulation. And believe me, there are issues with emulation, especially if you're doing, like, I would say deep type code execution, right? So if you miss a bit or two here and there, it can be like, it can be disastrous to the application, create bugs that you don't even really understand, right? So with these more robust systems, again, going back to my comment earlier, is that you can build much bigger apps or bigger programs
on ARM now that we have these more robust workstations and servers that we can use to do it on. You used to only be able to, unless you could afford getting a big system, right, which were thousands of dollars, you used to kind of be forced to build on your Raspberry Pi or forced to build on some of these very low compute devices. Now you can build on these big old servers on ARM for a smaller ARM device. So
there were some companies that offered, like, I remember, and they're pretty popular these days. I think they got kind of acquired and merged, but there were companies that were offering like bare iron ARM virtual, like cloud services. So like you could leverage that that cloud provider. They had a bare metal ARM server for you to use. Now, I don't know what that looked like on the back end. Was it a Raspberry Pi? I don't know. Was it, something, maybe a proper server? That's okay. But, this existed before. But I think now that, people are figuring out, or at least the ARM folks are figuring out how they can, drive up the processor's processing speed and maintain a low power consumption, right? That's always like the balance, striking that balance. Whereas like x86 is really good at fast compute, heavy on the horsepower, but it's a mess, right? With power, managing power and power consumption, right? So you're striking a balance. But now we have, ARM is actually making huge strides, which is why you're seeing now, some of these applications, like you said, that are traditionally not like ARM device type applications. Now we're talking about server and maybe even like Kubernetes type applications, right, running on ARM, which is awesome.
I turn my desktop on every morning, okay, and the room is cold. By the end of the day, now I'm sure that's also coming in from other areas of the house, but by the end of the day, you can feel the heat coming off my computer here. It's warming up the entire room.
Right.
So definitely feel that. So Angel, we're gonna run out of time if we don't get to your demo, but I do have one last question, and then we'll dive into it. With all these other CI/CD platforms out there, and let's not mention any names because I think that they're all amazing. They're all doing amazing things. What is CircleCI's secret sauce? Like, how do you differentiate yourself in this industry, to other CI/CD platforms?
Well, I already kind of mentioned that, right? Like, developers don't need to worry about infrastructure, CI/CD infrastructure. You don't need to worry about installing things. You don't need to worry about securing these things. You don't need to worry about the networking, right? That is involved. All the details that are involved with managing your own hardware and your own infrastructure goes away, right? So that's one aspect to it. That's one differentiator. And competitors do have like cloud offerings. But I think the biggest the differentiator for CircleCI right now is that we only care about continuous integration, continuous delivery. That's our focus. Whereas a lot of our competitors are not focused on that at all. Actually, they're competing amongst themselves. They're essentially, I want to say, more of code repositories that added CI/CD as a feature, right, to kind of compete with one another and also give their customers that automation, right? That's, and it makes sense, right? So if you have your code, if you have control over the code, you should have some mechanism for your developers, your customers to run some sort of automation on that code. The problem with that is you're providing now kind of an all-in-one solution, and the focus is on a lot of things. And you know what I mean? Like, if you don't really specialize or focus in on one thing at a time, or one thing really well, you can see where like the differentiators and the performance, right? Like, it's not that great. CircleCI, we're all about performance. We're all about measuring. We've been around for 9 years, and we want to make sure that all of our customers' pipelines are running efficiently. They're getting the support and the resources that they need to be, again, super efficient and run their pipelines as optimized as possible, which is not happening on other competitor sites. There's always there's always little cons to everything, but I think with CircleCI, you have way less cons in running your code on our platform than you do on somewhere else, right? And again, things are implemented different ways. I've seen like a whole bunch of different complaints about our competitors, but I have to say the differentiator is we focus in on CICD being the best at delivering those services and helping developers, get where they need to be as quickly as possible, consistently and reliably, right?
Very nice. Very nice. I think
Right.
well said.
Is that good enough a sales pitch?
Oh yeah,
Even though I'm
that
not a
was
sales
great.
guy, but
You did great. You did
It's all
great.
good.
So we have another question from the audience, but we'll take that after the demo just in case we run out of time. So
Yeah,
Angel, running through this, I know you have some prerequisites. So you're going to share your screen here real quick. We'll go through some of the prerequisites. Then you're going to walk us through some code, and then you'll show us a deployment. So you want to pull your screen up here real quick so we can share it with the
Let me
audience
grab. I just accidentally closed this this project that I was going to show you. So let me grab that real quick.
That's
and
all right.
then we'll jump right into it.
And then also, for anyone who is watching or watching later, this is the blog. So you can go to circle.ci/ARM blog, and you can follow along and or just do this demo on your own. There's lots of cool stuff, and Angel's going to walk you through it right now. We're going to do a condensed version of it.
Yeah. Let me jump in here real quick. I know that where. Oh my goodness. Oh, here we go. Share your screen. Sorry. I'm jumping around all over the place. Let me knock down this.
You're looking up, you're looking to your side. How many monitors do you have there?
I just have one big one and one other big one. And it's like, I'm super close to them, which I still haven't figured out, like the distance thing. It's a whole mess, but
all right.
Can you see that? Yeah. Awesome. So this is the blog that you were talking about. If you want to follow along later, the example is there. I'm sorry. Let me zoom in on that a little bit. How's that? That look good?
Better.
All
Yeah,
right,
much better.
So this is the prerequisites. Essentially, what you're going to do, there's a Git project out there. You can just jump in there. All the things are in this blog post. So if you miss something now that I'm showing you, just go through it. It'll kind of walk you through everything. What I'm leveraging here is we're going to be using Docker. So I build Docker images, and I'm going to send it up to Docker Hub. I really like to keep things as open as possible, so I try to use as much, or provide as much open source things as possible. Docker Hub's a great open source or open kind of repository for images. So we're using that, leveraging that. Let me go back to the thing. Yeah, and then we're gonna. I like to build infrastructures using infrastructure as code versus going into a GUI or graphical interface and pointing and clicking and typing and all that good stuff, right? I like to type once and then execute many times later. I'm leveraging Terraform, which is a infrastructure as code tool provided by HashiCorp. Great bunch of folks over there at HashiCorp. The tool itself is open source, so that's cool, right, as well. So yeah, you can leverage Terraform, and there's good examples for that. And then, of course, I'm going to leverage, as you mentioned earlier, Robert, the AWS Graviton 2 instances that are going to be compute nodes that are going to compose my Elastic Container Service cluster. We're going to kind of show you a pipeline and the CICD pipeline that's kind of built on ARM, right? And then it's going to deploy to ARM resources and infrastructure, right? So it's an ARM pipeline end to end, right? So the other thing I wanted to show you was, the CircleCI pipeline, the CircleCI dashboard. So this is essentially where you go to watch your stuff happen, right? Everything you do in CircleCI regarding a pipeline development is done in YAML. And we call that a CircleCI configuration file. But those are the major bits that, for this demo that you're going to require. So let's go ahead and jump into, I guess, the demo, right? Because we're going to run out of time here soon.
Yeah, let's do it. Save yourself a couple minutes for the shameless plug.
Yeah, no worries. I'll shamelessly plug as I execute this thing.
All right, sounds good.
All right. So what we want to do here is This is the configuration.yaml. So what I'm showing, let me plus that up a little bit, make it look real. That's better, right? So what we have here is a project, which is this is my version of the blog project. So it may look a little different, but essentially almost the same thing. But this is my forked version of that project. So what we have here is essentially to get CircleCI implemented into your project, right? The first thing you need to do is sign up for a CircleCI account on CircleCI.com. Just sign up. All it does is a OAuth ceremony, which authorizes CircleCI to monitor your GitHub repositories or your GitHub repository for any changes. Which means when you push any changes upstream to that repository, CircleCI will detect it and it will kick off this pipeline that I'm showing you. So go over there and do that, and then get yourself a CircleCI account. Oh, by the way, we give you about, I think it's 200 build minutes per week, so that you can get to know the platform, build open source projects. We have a very liberal open source policy that we give a little bit more. We give more build minutes to open source projects. And I think that's like right off the bat, they're available to you. If you have any issues with that, hit me up and I'll get you connected to the right people. So anyway, the first thing you want to do is create a .circleci folder. Then within that is your what we call config.yml file. And this essentially is the instruction for your CICD pipeline. The way that it's composed, there's pretty much three different elements to it. The main components are jobs, which are a list of commands that you want to run. So a job is considered a grouping of commands that accomplish a specific thing. In this case, I'm going to run my unit tests, right? And as you can see here, the one thing you need to implement first is a name. This is just a label, right? So identify the job. Once you have that key in place, you want to tell it to where to run your code, right? So this is where the CircleCI resource class comes into play. So obviously, right, we're going to execute things. We need a host to execute on. And this is where we call what we call an executor. In this case, we're going to basically assign what we call a virtual machine. It comes in 4 flavors. You can actually run this in a Docker image, right? Or a Docker container, I should say. So like if you have a Docker container with everything installed, you could actually build your software in that container. In this case, we're going to use ARM. So we're going to use a virtual machine. And we're going to tell it what operating system we want to use. I'm a Linux guy, so I'm going to be using Ubuntu in this case. And then here's how you tell it you want to run an ARM executor. Essentially, just tell it the key resource class. And we have 2 flavors right now. It's a fairly new feature. So we have ARM .medium, which is like 2 CPU and 8 gigabyte of RAM. And then the ARM large is double that. But we're adding more capacity to these eventually. But right now, this is what we kind of came up with to introduce the feature, and it's been pretty performant for pretty much all of our ARM interested developers. Finally, right as I said before, this is a job, and a job is the collection of commands that you're going to run to achieve a specific goal. In this case, again, we're running our unit test for our application. And we're also leveraging what we call an orb. And an orb is essentially, think of it as like an import statement for a package of configuration. So if you have, let's say you do node install all the time, right, or npm install all the time, we've kind of encapsulated that functionality to make it easier for developers and less volume in syntax in your YAML. So it's an encapsulation method or mechanism. And what we've done here is now we're implementing the node, the node orb down here. So you would say node / and this is the function or parameter that that is encapsulated inside of that functionality. In this case, I'm going to install my packages, right? So I want to run an install command for npm. And then also we have a caching mechanism. So this enables your jobs to be able to cache this stuff and then cache the dependencies, so that when you start a new job, a subsequent job, like maybe another pipeline, those things are already cached. You don't have to download it, right? So that decreases your build time, which is great, right? You don't have to wait around for things to download. It's already kind of there. And that's what caching is great for. And then finally, right, I want to run my my unit test. And again, right, so here's a run command, what we call a run block. And then in there, you can like give it a name. And I'll show you what that all looks like in the dashboard. And then finally, I'm just running my my Mocha test command, right? And then I'm also packaging those results up into some test artifact files. And then I'm storing these, right? So you can actually pin this to a build, right? So that everything's kind of packaged up nicely. You know the test results. If you need to go back and you know, kind of troubleshoot something in previous builds, you have all of that information there. So that's like the run test job. Let's talk about building Docker images real quick. What I mentioned earlier was, I'm sorry, let me close. I like to keep these jobs closed so that, you know, the focus is on the specific thing. In this case, we're just using another orb called Docker. And essentially, it just makes things super easy. As you can see, with a few lines of code, I'm, again, instantiating an ARM medium resource class because I need to build an ARM-centric Docker image, right? And the only way I could do that is having the underlying kernel support the Docker architecture. So that's why we need the ARM medium. One other thing I want to say, if you're building Docker images, you definitely... What happened here? Okay, cool. You definitely want to inherit from an ARM, I guess, an ARM enabled or an ARM capable Docker image, right? So Docker does this inheritance through what they call caching layers, right? So everything starts from somewhere. You definitely want to make sure if you're building a Docker image that you have this at a minimum. I don't care about the you would care about the version. They have a version 7, I think. But, you know, whatever version you're targeting, but you definitely want to have this prefix before your Docker container so that, you know, you're basically telling the Docker build process, yo, grab the ARM64 container and build off of that and, you know, off of those layers. So I covered that. I'm going through this really, really quickly. Or do we have a hard stop, Robert, or is it like, you know?
I'd say I know where this demo goes, so I'd say let's get to the point where we deploy it.
Yeah,
so
let's do that.
Smash that button, check out the dashboard, and then we won't be able to do the destroy section. But
that's all right. That's in the. We'll have some content on that later, right?
Yeah.
All right, cool. So let's look at the app, right? Like, so normally I would say don't focus on the app. The app doesn't matter in this case because I'm demonstrating CICD, not the application. But this is a simple static node application. I'm going to go ahead and just change a version, right, to make some code changes. And I'll use normally I do this in the terminal, but I'll just use this IDE to do it. Well, actually, check out the terminal here. So let's do a git status. A git status, right? So I made some code changes. And yeah, so my app.js changed. So let's just do git commit. Now this is where I'm going to commit locally. My application changes. And then we're going to do a message. I don't know, not a capital M because that'll make it a boo-boo. Let's say, I don't know, updated version. Yeah, that's fine. So now I've committed that locally. And all I got to do is a git push, right? So this is the normal developer workflow. If we jump back over to the CircleCI dashboard, this should pick up my change. There it is. So CircleCI detected that new code commit or code push, I should say, upstream, and it's now kicked off my pipeline, right? So what this pipeline is doing is essentially running that unit test section that I showed you. It's building my Docker image for ARM, and you can see what's happening there. Let me go back one. That's just spinning up the environment. But as you can see, it already, look, in 24 seconds, right? It spun up an environment, tested my code, and hopefully my test passed. Yeah, it looks good, right? And it pinned everything up to, let's see, let's go to tests, artifacts. I have all my test results here. If I click on that, look at that, right? Nice, and everything's nice and neat and pinned to the version of the software that was tested. So going back to the pipeline, did I just close my pipeline? I did. All right, cool. So I'll show you another way how you can get to this pipeline. you can actually just click on, let's go back. Sorry. In GitHub, where is my, anyway, doesn't matter. We'll go back to the regular. I forget where that, I think you have to do it in a PR, but I wasn't in a PR, so.
So one thing to note here,
Yep.
Angel and I met last week or 2 weeks ago now, and we built out a 6-part series for a new ARM software developer breakdown that will be coming out in the coming weeks. So this demo is thoroughly discussed and walked through in that series. So you'll still get a chance to see it in more detail during that video series. Of course, it complements the blog that we've been mentioning in this live stream as well.
Yeah, finally, I just want to talk about this. I know we're bumping up against the stop. So so as I just clicked into, let me go back into, here. So I clicked into my deployed at AWS, right? So my Docker image was built, and now I want to go into the Docker, the Terraform that's deploying my Elastic container service. And essentially, right, I'm leveraging another orb that's called Terraform, which again eases that whole implementation of Terraform into your CI/CD pipelines. And right now, right, I'm building a lot of things. I'm building a VPC, I'm building subnets, I'm building security groups, I'm building ECS cluster, I'm building IAM roles, right? All through this infrastructure as code mechanism using Terraform. And eventually what's going to happen is if we jump over to my AWS console and look for ECS, should be able to, not EC2, ECS, let's try this again. And that's a container service, right? So this is a service that enables you to host your applications in a very robust environment. So it's kind of like a, I don't want to say Kubernetes light, but is definitely like a Kubernetes-esque. It's an orchestration platform, right? Specifically on AWS, which I like to use for, a lot of my minimal viable product testing, research and development, hacking when I'm doing hackathons. But what you see here is it created a new cluster for me. And at the end of this whole process, we will have a fully functional ECS cluster that's based off of AWS Graviton 2 ARM compute nodes, right? So that's where you're getting, like, not only in CircleCI are you building all of your ARM infrastructure natively on ARM hardware within CircleCI's infrastructure, you're also deploying, with this example, to a fully ARM-powered ECS cluster using the Graviton 2 compute nodes. So yeah, it's let's go back to the pipeline and see where we are on that. It takes a little bit of time because I don't have any control over AWS and how they build things or how they're processing my requests. But it's still pretty quick, right? Like, so from back in the day when I was building things, I was literally, if I wanted to deploy something like this, I had to essentially build my own rack, get the wiring in, right, for networks, to make sure I had the fiber in, the ether in, all these like expensive hardware, and then the labor behind it, right? It's just, and then the security, physical, and then information security. There's a whole lot of things going on that are kind of abstracted away now with all these cloud providers, and we rely on them to provide that stuff for us, which is pretty awesome. But at the end of the day, we get this pipeline will end. This finished. So, but that still doesn't mean that this cluster is completely built, right? We just set that command off. Well, here you go. So the service has been established for ECS. If you drill into that, you can see, like, this is what we call a task definition, which is basically it hasn't been issued yet. It will be in a minute. Like I said, right? Just because Terraform says, hey, this is done, doesn't mean it's actually done processing, right? But eventually it will on Amazon. What I did want to show, though, before we bounce, is the instances, right? So now, right, it's still creating my instance. It actually created one for me. And if we dig into that ECS instance, I just wanted to show everyone that, like, yeah, here's the instance type, right? And this is a T4G. The indicator for a Graviton is this G, right? So Amazon has a T4. If it's just a T4.medium, then you're talking about an x86 instance. if you have a Graviton 2 instance, that G after the the T4 is the indicator for a Graviton 2 instance. So if we go back to ECS, let's do a refresh. I just want to show the app working to make sure that folks are like, all right, this is legit and not some BS demo. So let's grab this endpoint. So at the end of the day, right? So it built all these things. It also built an Amazon Elastic, or sorry, an Elastic app or an Elastic application load balancer. So essentially, what that does is basically puts a load balancer in front and enables traffic to be routed to those containers in your ECS node. So if we go here, there's the application working, version 7, right? Which is pretty awesome. And that's all from my pipeline. Now, real quick, we won't see the full destroy, but I wanted to show one more thing, which is
tear this down.
Tear this down, right? You don't want to have this up and running. I just want to show this demo to kind of give people an idea of what you can do with CI, right? You can build your infrastructures and your applications, and then you can also deploy them to a target infrastructure. So like if in production you're running things in ECS or Kubernetes or whatever other platform, you can create those things using Terraform, deploy this version of your application and run your tests, right? You can check deployment, like run some tests on that deployment, test a lot of the things, make sure the application is running as intended on that target infrastructure. And then finally, you could even set this is manual, but you could set this to destroy it once all your tests are done, which is what I did with this clicking of this button. I've told my pipeline to go ahead and tear all that stuff down. So now Terraform will kick off again and run the destroy commands, and then this infrastructure will no longer exist in about 5 minutes. So
okay,
that's it, man. That's
cool. Yeah, that's awesome. So I'm going to do a quick run through for you, Angel, real quick.
Man.
So first off, closing this out, I want to thank you so much for your time, spending this hour with us. We know it's valuable. All the viewers out there that spent your hour with us, thank you so much as well. To run through this real quick, right below me, you're going to see this link, CircleCI or circle.ci/ARM blog. You can find all of the information you need to go through this particular demo that Angel went through. Let's keep scrolling down the list here. Here's the link to the GitHub repository for the ARM executors. For the prerequisites, of course, all of this is available on the blog. We went through Terraform. You got to get set up there. You got to get set up through CircleCI to get your account there. You have to go get set up through Amazon, set your account up there. You can follow CircleCI on Twitter at CircleCI. Awesome. And then if you have any questions or need some support, you can go to discuss.circleci.com. Don't forget to follow our amazing guest here, Angel, at PunkData on Twitter. And last but not least, at the beginning of the episode, we gave a redemption time for Andrew Smith from Altium, who showed his drone that flew, and you can find all the information you need there here. Now, one last thing before we go, I want to make an announcement. Saw your face, Angel. What the heck just happened? Yeah, this just did.
I'm traumatized from all the news these days, right? So it's like, whoa, wait, am I on CNN here? All right, thanks.
Yeah. So this week and next week is the last, I think, weeks to submit a call or a proposal to the call for proposals. And I'm looking for the link here. I know I have it somewhere for Dev Summit, devsummit.arm.com. You can go there, submit your CFP or submit your proposal to the CFP. You have until June 4th. So if you'd like to speak at this event, it happens in October, go submit there. We look forward to having as many submissions as possible, and we absolutely look forward to our developers here on this call to be accepted. So make sure you go submit there. Now, last but not least.
Quick question about that. Is that live or is it hybrid or is it streamed? Or
it's a live virtual event. So
gotcha.
It's not in person. No, not this year.
Okay. No, just curious.
Yeah, so it will be live. There will be lots of really cool stuff happening, and you can go start exploring the devsummit.arm.com website to find out more about that. Now, Last but not least, we unfortunately bled a little bit into this particular other event. So DockerCon is happening right now as we speak, and there is a community room there where 3 of our ARM innovators will be speaking along with Arjit, one of our community members who does a lot of TinyML stuff. So cruise on over there. We're going to share this in the chat as well. Let's go raid that community channel. You might need to go register real quick, which is easy process. What's up?
I actually, so everyone here, excuse me, got a preview to a talk that I did. So what you saw here is kind of what my talk is going to be about. So you could probably skip my talk. If you want to watch it, do it. But no, I'd rather people, jump into, if they saw this, they should go and see, something else that will, instead of being repetitive. I'm just in your time. I'm just keeping it real. Yeah, I'd rather you spend your time more useful than, I would love for you to watch it, or maybe you can play it on 2 screens, right? That's awesome. Like
I added your talk to my agenda, so I'll be there supporting you.
Awesome.
But yeah, this community room, it's a little different. They've done it DockerCon this year, from what I understand. This is just like a nonstop room. It's just open, and people are going to be coming in and talking. So it's pretty cool. You can go watch all these different sessions. And like I said, 3 of our ARM innovators will be speaking at this particular community room.
I've spoken at the past 3 DockerCons, and it's a pretty good event. So I encourage you all to go. Like I said, if you already saw this, so if you want to skip mine, go ahead, jump into something more useful or something new. But I'll be there chatting as well. So if you want to reach out to me, then I'm totally down to talk as well.
Awesome. Well, let's cue up that outro. And thank you so much, Angel, for joining us. Everyone in the audience, cruise on over to DockerCon. Make sure to submit your paper to the CFP. And Angel from CircleCI, wonderful having you on the show. So thank you so much.
Same here. Right. And I look forward to coming back one day, man, and doing some more cool stuff.
Anytime.
Thank you, Robert.
Come on back anytime. All right. Thank you all. Have a nice day.